Good noon, everyone. Very welcome to the 7th IMEC and 16th APM. This is Fateh Azam Mahmood, Sales Consultant Engineer from Atlas Copper Bangladesh Limited and ex-student of Chittagong University of Engineering and Technology. This is a project named Development of Automatic Wall Painting Robot. This is a project that is a combined work of 5 persons, 5 authors. We are here. Fateh Mahmood, Amin, M. Mominin, M. Shahriar, and the Honorable Supervisor, Dr. Tazul Islam sir. He is actually the coordinator of this project. Actually, for what I'm doing this project, I'm just presenting that at the first time. You know, at the world, there is everything is automated, but there is very few contribution on the automatic side. On the, if you think that is on the painting sector, that has been automated, but for the construction sector, that is there is very few idea that actually influences me, pursues me to do such a project. You will be actually amazed to think that there is so much automated screw melting at a large company, at ABB, at Atlas Copco, and welding. The people do this one. So this type of project can help such thinking. And I, at first, very beginning of this project, I want to say you people that this is the prototype, this is an idea. And then if you implement it in a big and larger scale, then this can be promoted. Objectives are, for what if you are actually listing the objectives, you'll see that to design a wall painting robot model, at first I had to do that on a software, and then fabricate the wall painting robot. Actually, I have to design the skeleton of that robot and the performance, what it is doing. Then I'm going to the next slide. Here, I concern these things. I just make a robot and it does not work or it does not efficient, then it will be just worthless. And for that reason, I just first think this type of concern. You see here, it must have a capacity equivalent to or greater than a skilled worker. It should be skilled more than worker, then it should be efficient. It should save energy. It should be able to paint walls. Operation of the robot body and its moving equipment must be possible by one-man control. If I make a robot that should be controlled by so many persons, that engage so many persons, then it will be problem, it will be inconvenient for a factory to control such a robot. Not obviously optimistic solution. The robot main body must move precisely to its proper work position and maintain that position. It must have safe operation. I'm going to the next one. That is the fabrication by which components I fabricated my robot. The mechanical wall, that is with the frame stand. I had a frame stand of aluminum, which I will show on the next slides. I'm just printing here. Plastic wheel, you see it in the robot. There is a plastic wheel to move forward, caster. There is a move backward. The chain mechanism was used. And sprocket, there was a sprocket there. Bearing spray can just to actually paint the wall. And electrical components is here. Wiper motor, DC motor, power supply, servo motor, resistor relay, and RGO Mega 2560. This is actually the briefing of my main components. DC motor are 12-volt DC motor I use for the forward motion. I'm saying again for the forward motion. I have used here 3 motors: DC motor, wiper motor, and servo motor. I'm going to the next one. Here you see actually the built-in RGU. I'm just skipping this one for the time being. And the second one, that is for the wiper motor and the servo motor. Wiper motor were used for the vertical movement of gear and chain mechanism, and the servo motor, that was the 10 kg servo motor bracing system. It braces the 10, and whenever the program is on, then it just going to the spring. I'm just clearing that on my next slides. This is actually the outline design what I have already said. The project aims to build an automation process replacing a painter for painting a vertical surface. The robot is mainly based on ball gearing and chain mechanism. And the dimension I'm saying here, it will be 1.5 feet in 1.5 feet and 1 feet in width, and the height will be 1.5 feet. This is the design. At first, whenever I just proposed this design, this is the design in the software. You see, just there's a very top point. There you see the chain, and just inside the chain there is a sprocket. And just outside there you'll see that spray can. There is a battery as a power supply, 12 volt lead-acid battery. And there is a socket board where I've said you the Arduino 256. There is a built-in Arduino pin. And the aluminum board to hold this one. It is like H wheels and wheel and caster and ball bearing. And there is a bush. This is actually the graphical overview of my robot model, how my robot will work. That first I have to give the power supply, from that the power takes, and then the Arduino 256 that works visually. Then servo motor presses the can spray. Then wiper motor drives the chain. Then a DC motor drives the robot forward, and robot continues painting and moving. That means it's going on such like that. The robot at first doing the painting, then it goes after some while. I am saying that while how moment it can be at the last slide, then it goes to the forward. This is the installation. I have already said these things here. This is my installation pic, the prototype what I did in this project. And that you'll see there, this is the top view. From the very top view, you'll see this one. There is a can spray. I'm just briefing here. This is the can spray. At the can spray, there is you see there is the black portion. This is actually a servo motor, 10 kg servo motor. It can press, it can keep 10 kg mass to the here. Then you will see there is a chain and sprocket and aluminum structure and lead-acid battery. Then the program Arduino 256, and there is in this is the actual wheel. In this case there is a caster, and the next one is just nothing, another pic, the front side view of that present. Actually I missed one. There is one. This is the wiper motor, but I could not make you see on that first one. This is actually a performance test. I'm just saying what a result outcome was at that time. The performance of robot is quite satisfactory on my view. And the robot can spray upward continuing 800 millisecond pulse programming. It basically thinking that 6-inch in length. I had the robot was very small in structure. I have already said 1.5 feet, 1 feet, 1.5. 6-inch in length and goes downward, maintaining same direction. That means it goes to the 6-inch to the downward, then it goes to the 6-inch to the upwards. The robot can move after developing period. That means it first goes to the painting, then it goes to the bottom. And that is the time duration is the 3 milliseconds, and the period is about 10 seconds. That means after 10 seconds, after spraying 10 seconds, then it goes forward. Then I'm coming to the statistical thinking. That is 12 volt power supply. You can do this one for the 3 hours. Then I'm going to the conclusion of mine. That is actually for what thing I will do this one, or how, or what the man will take this step project. That is what the quality, productivity, and safety. That is 3 master of the production. At first you have to think of quality, then you have to think of productivity. If this is not the productive one, if this is not the resulting one, you will not make this one as safety. And I believe this type of well-painting robot can make you safe from the eye and respiratory. And you will see sometimes when such printing, you have some problems in eye respiratory system. Actually, the people will sometimes injure. So if I do such type of, if I can sponsor, if I can make these things at a larger version, then it can be a more productive one. What you were saying, that is just a prototype, and this is just an idea. And I believe this can reduce labor cost, this can reduce workers' fatigue. Sometimes you think he's spraying, and he is spraying until he's dead, and his lifetime is just reducing. He's intoxicating. If you think the toxicity comes to his body, and then minimize the cost of painting, I believe if it came in the larger scale, the cost of painting will be reduced, and construction process will be more accurately managed. Thank you, everyone. Thank you for listening here.
Thank you, Mr. Mahmood, for your nice presentation. So, very few questions again.
First of all, I think there are some limitations.
Obviously, apparent limitation.
First one, without track, running track, it cannot climb higher. For example, 3-4 feet for the floor without track, because the spreading system is a chain.
Yes.
So without the tracking system,
Yes.
Okay, it cannot climb the higher length.
Yeah.
And another one is there is some preciseness for painting. The wall is, for example, wall is square.
Yes.
So when we paint different color in art. So for example, here is a red and another one is blue. So it's sprayed. The nozzle system cannot control their painting area. That is why this is not appropriate for wall painting, I think. For example, it's also appropriate for car painting or car body painting because there is a lot of limited area. That's why it cannot appropriate for wall.
Very thank you for your information, and I'm just adding another limitation of my project. Actually, we are thinking of doing that limitation we cover. The first one, that is what you want, color changing. I need the color change. First one.
No, you have to control the nozzle.
Nozzle color change. The second one, it presses whenever I go the program, but it does not actually go for the obstacle. If you press here, it will spray. This is a very big problem for these types of things. You have to have this sense, this is a wall. Yes, this limitation I had in mind, and I will just modify this.
How do you overcome
We are
this?
just doing this, and already we have the obstacle avoiding grip robot, and I'm thinking just to conjunct, just to make a connection with those things. And we have so already a 5 limitation at least.
This robot has a self-climbing capacity in a wall.
Self-climbing capacity in wall, that is climbing means whenever you're thinking just up, down and downward, then it has our program. But whenever the climbing is just touching to the wall, and then it will go to no that one.
In this prototype, I can see it only moves vertically. If you move horizontally, you have to.
Yes,
you have
that's
to
one.
pull robot.
That is also my concern. I had said you that this can do only vertically upward and downward. I just did not see saying that it will go painting forward.
I'm sorry. The discussion may go on. I'm also encouraging this discussion, but the time is very short. So sorry.
Thank you very much.
If anybody have very specific questions?
Okay.
So thank you.
Thank you very much for the.
For your nice presentation.